Article 110.26 of the National Electrical Code, also known as NFPA 70, mandates a dedicated working space in front of electrical equipment. This includes electrical panels. The code specifies a minimum clear space of 36 inches in depth, 30 inches in width, and 6.5 feet in height. OSHA Regulation 1910.303 integrates the NEC electrical safety requirements, which includes the working space provision. This working space is absolutely essential for the safe operation and maintenance of electrical equipment. It serves several critical purposes. Firstly, it ensures unimpeded access to controls and circuit breakers. Secondly, it facilitates the safe handling of tools and materials needed for maintenance and repairs. Thirdly, it allows for proper ventilation and cooling of the equipment, preventing overheating and potential failures. Fourthly, it provides sufficient space for emergency response and evacuation in case of electrical incidents. While OSHA regulations do acknowledge certain exceptions to the working space requirement, these are typically allowed only when there's a clear need for physical protection from specific hazards. However, it's important to evaluate whether the implemented protective measures actually provide adequate protection. In the specific scenario of a guardrail installed to prevent forklift damage, several factors must be considered. The guardrail's height and proximity to the electrical panels are crucial. If the rail is too low or too close, it may not effectively prevent a forklift from impacting the equipment. In fact, it could potentially create a new hazard by obstructing access to the panels or hindering emergency egress. In such cases, the guardrail installation can be deemed a violation of both NEC and OSHA regulations because it restricts access to the electrical panels and poses a safety hazard. Therefore, it becomes necessary to either remove the guardrail or modify it to fully comply with the minimum working space requirements outlined in the regulations. Ensuring adequate working space around electrical panels is not merely a matter of compliance, it is about prioritizing the safety of personnel and maintaining the integrity of the electrical system. By adhering to the NEC and OSHA guidelines, organizations can mitigate the risk of electrical accidents, facilitate efficient maintenance procedures, and create a safer working environment for everyone involved. To further elaborate on the specific dimensions and requirements for working space around electrical equipment as defined by the National Electrical Code, let's delve into the details. The 36-inch depth requirement is measured horizontally from the front of the electrical equipment to any obstruction, such as a wall, partition, or in this instance, a guardrail. This depth ensures that personnel have sufficient room to stand, move, and operate equipment safely without being cramped or restricted. The 30-inch width requirement specifies the minimum horizontal clearance around the electrical equipment. This width allows for adequate lateral movement and access to different components within the panel. It also provides enough space for multiple individuals to work simultaneously if necessary. The 6.5-foot height requirement establishes the minimum vertical clearance from the floor to the lowest obstruction above the electrical equipment. This height ensures that personnel of various sizes can comfortably access and work on the equipment without having to stoop or bend over excessively, which could increase the risk of strain or injury. In addition to these minimum dimensions, the NEC also addresses the concept of dedicated equipment space. This refers to the space directly above and below the electrical equipment, which must be kept clear of any foreign objects or obstructions. The purpose of this requirement is to prevent accidental contact with energized parts and to ensure that the equipment can be properly ventilated and cooled. Now, let's consider the implications of a guardrail that obstructs the working space around an electrical panel. If the guardrail is positioned closer than 36 inches from the front of the panel, it violates the depth requirement and restricts the space available for personnel to work safely. This could make it difficult to open the panel door fully, access the circuit breakers, or perform maintenance tasks efficiently. If the guardrail is narrower than 30 inches, it violates the width requirement and limits lateral movement around the panel. This could make it challenging to reach different components or to work with tools and equipment comfortably. Furthermore, if the guardrail is less than 6.5 feet tall, it violates the height requirement and obstructs vertical access to the panel. This could force personnel to stoop or bend over, increasing the risk of strain or injury. In summary, a guardrail that infringes upon the minimum working space dimensions established by the NEC poses a significant safety hazard. It restricts access to the electrical equipment, hinders maintenance activities, and increases the risk of accidents and injuries. Therefore, it is essential to ensure that any guardrail installation fully complies with the NEC requirements to maintain a safe and efficient working environment. It is also important to understand the specific exceptions to the working space requirements that may be permitted under certain circumstances. As mentioned earlier, OSHA regulations do allow for exceptions when there is a demonstrated need for physical protection from specific hazards. However, these exceptions are not automatically granted. The employer must conduct a thorough risk assessment to determine the potential hazards and the appropriate protective measures. If a guardrail is being considered as a means of protection from forklift damage, the employer must evaluate the effectiveness of the rail in preventing such damage. Factors to consider include the height, strength, and location of the rail, as well as the type and frequency of forklift traffic in the area. The employer must also assess whether the guardrail creates any new hazards, such as obstructing access to the electrical equipment or hindering emergency egress. If the risk assessment concludes that the guardrail is not the most effective means of protection or that it creates additional hazards, the employer must explore alternative solutions. These could include relocating the electrical equipment, implementing traffic control measures to prevent forklift collisions, or installing more robust protective barriers. In any case, the employer must document the risk assessment and the rationale for the chosen protective measures. The documentation should be readily available for review by OSHA inspectors or other authorized personnel. It is important to note that even if an exception to the working space requirements is granted, the employer must still ensure that the electrical equipment is accessible for maintenance and repairs. This may involve providing a removable section of the guardrail or developing a specific procedure for safely accessing the equipment when the guardrail is in place. Furthermore, the employer must train employees on the proper procedures for working around electrical equipment and for removing or modifying the guardrail when necessary. The training should cover the hazards associated with electrical work, the importance of maintaining working space, and the specific steps to take to ensure safety. In conclusion, while OSHA regulations do allow for exceptions to the working space requirements in certain situations, these exceptions are not automatic and must be carefully evaluated. The employer must conduct a thorough risk assessment, implement appropriate protective measures, and provide adequate training to employees. Only then can the employer ensure that the electrical equipment is protected from hazards and that personnel can work safely around it. Now let's delve deeper into the specific aspects of electrical safety regulations concerning the installation and maintenance of electrical panels, focusing on the practical implications of these regulations. Electrical panels serve as the central distribution point for electrical power within a facility. They house circuit breakers, fuses, and other protective devices that control and protect the various electrical circuits throughout the building. Because of their critical role, electrical panels must be installed and maintained in accordance with strict safety standards to prevent electrical hazards and ensure reliable operation. One of the fundamental requirements for electrical panel installations is proper grounding. Grounding provides a low impedance path for fault currents to flow back to the source, which helps to trip circuit breakers or blow fuses quickly in the event of a ground fault. This prevents electrical shock hazards and reduces the risk of fire. The National Electrical Code specifies detailed requirements for grounding electrical panels, including the size and type of grounding conductors, the methods for connecting to the grounding electrode system, and the bonding of metallic enclosures and raceways. Another important aspect of electrical panel installations is proper labeling. Each circuit breaker or fuse must be clearly labeled to indicate the equipment or area that it serves. This allows personnel to quickly identify and energize the correct circuit for maintenance or troubleshooting purposes. The labels should be durable and legible, and they should be updated whenever changes are made to the electrical system. In addition to grounding and labeling, electrical panels must also be protected from physical damage. This can be achieved by locating the panels in areas that are not subject to impact from vehicles, equipment, or other objects. If the panels are located in areas where they are at risk of damage, they should be protected by barriers such as guardrails or bollards. However, as we have discussed earlier, any protective barriers must not obstruct the required working space around the panels. Electrical panels must also be properly ventilated to prevent overheating. The heat generated by the circuit breakers and other components inside the panel can cause the equipment to malfunction or fail if it is not properly dissipated. The NEC specifies minimum clearances around electrical panels to allow for adequate ventilation. These clearances must be maintained to ensure that the equipment operates within its rated temperature range. Furthermore, electrical panels must be kept clean and free from dust, dirt, and other contaminants. These contaminants can accumulate on the electrical components and cause them to overheat or malfunction. Regular cleaning and maintenance are essential to ensure the reliable operation of the electrical panels. When performing maintenance on electrical panels, it is crucial to follow safe work practices. Only qualified and trained personnel should perform electrical work, and they should always use appropriate personal protective equipment such as insulated gloves, safety glasses, and arc flash suits. Before working on any electrical panel, the power must be de-energized and locked out to prevent accidental energization. Lockout-tagout procedures should be followed to ensure that the circuit cannot be inadvertently turned on while work is in progress. Once the power is de-energized, the electrical panel should be inspected for any signs of damage or deterioration. Loose connections, corroded conductors, and cracked insulation should be repaired or replaced before the panel is re-energized. All electrical connections should be tightened to the proper torque specifications to ensure reliable performance. After the maintenance work is completed, the electrical panel should be thoroughly tested to verify that it is functioning properly. Circuit breakers should be tested to ensure that they trip at the correct current level, and insulation resistance should be measured to check for any leakage. The electrical panel should not be re-energized until all tests are completed and any problems are resolved. In conclusion, electrical panels are critical components of any electrical system, and they must be installed and maintained in accordance with strict safety standards. Proper grounding, labeling, protection from physical damage, ventilation, and cleanliness are essential for ensuring the reliable and safe operation of electrical panels. By following safe work practices and performing regular maintenance, organizations can minimize the risk of electrical hazards and maintain a safe working environment.